All right, so this particular problem down here on the third page, bottom right of the worksheet, yeah, this one right here, that's got tangent secant squared x, looks really difficult. But what I'm thinking in my brain is, first of all, can I let u be one of those and the derivative of u be the others through u substitution? That's what this whole thing's about, u substitution. And that's going to be the main thing you see on the AP test is u substitution problems. So you not only got to know your basic rules, you got to know your u substitution. So what I do notice is I can split this thing back up and put one of those secants in front of the tangent x, and I'm going to leave the other secant out here by itself, and I can separate them a little bit, and I can do the integral of all of this. Now, what that does for me is I know my derivative rules. And I know that if I take the derivative of secant, the derivative of secant is the secant tangent. So that I can now take this thing and let u equal the secant of x, and then the derivative of secant would give me secant x tangent x. And I take the dx that was under there and move it over here. So if you look, this part right there is the du part. I'm just going to stick u in where secant is. So this would be the integral of u du. And that's u to the first. So then I can take the rule that says add 1 to the exponent, divide by it plus some c. And then what that gives me, in other words, I'm going to use this to come over here. I can stick secant back in for u, and I would get 1/2 secant squared. You could just put the secant squared x over 2, but I'm going to move it out like it's a coefficient plus c, and that right there is what that would be. So pretty tough problem. Again, you need to practice these because they're all over the test. Yes, ma'am. I cannot hear you. Can you also do what?
Can you also put tangent as equal to secant?
Yes, you could have also said u. I didn't think of that, but it would work. You could have said u equals tangent x, and the derivative of tangent x is secant squared x dx. So let's look at this. So I'm going to erase all this stuff and do the same thing. So this would be leaving it like it is originally. Yeah, that would have been even easier probably. I don't know. There's more than one way to do all of these. So anyway, so then this would be, again, the integral of u, because I'm sticking that in for tangent, sorry. And then secant squared dx is du, so this would be u squared over 2 plus c, which would also equal tangent squared x. So there's actually two different answers that would work for this problem. Oops, it'd be a half in front. I forgot to put the half from that 1 over 2. So yes, that would work. That would work, and it's the same, give you the same result. Looks different. There, that's okay. What else we got? Anything else? Yeah.
This is like a worksheet, but did you just do a video of your example 12 and 13, 6, 9?
Okay, I thought I just said that. I forgot to do 12 and 13 because the sheet stuck together. So I didn't take a picture of it, and I'm going to do it right after this class and post those. Anybody else? I'm going to pause this video so that I don't have a bunch of dead space.